Okay, so we're going to do 13.14. So again, we are given a cost function C equal to 15Q minus 6Q squared plus Q3. So the firm can sell any amount of output it wishes at the price P0 equal to 15. Okay, so the firm is just the price taker, and this is the price given in the market to the firm. So write out the firm's total revenue, average revenue, marginal revenue functions, and also the firm total profit function. Okay, so total revenue. So total revenue is just going to be the price times the total quantity the firm is selling, and the firm can sell anything at the price P equal to 15, so therefore it's become 15 times Q. Okay, so depending on how many units of output is selling at the price of 15 each, and that is going to give the firm the total amount of money the firm is going to get. Okay, now average revenue is just going to be the total revenue divided by quantity Q. So it's just 15Q divided by Q, and so that is just 15. Marginal revenue is just going to be the differential of the total revenue with respect to quantity. So if I differentiate this, I'll get 15. Okay, and the firm's total profit function. So the profit is just going to be the total revenue minus total cost. Now total revenue is 15Q and total cost is 15Q minus 6Q squared plus Q3. Okay, so therefore if I simplify this, 15Q minus 15Q is 0. It becomes 6Q squared minus Q3. Okay, so that is my total profit function. So part I asking you to confirm that the firm breaks even. The profit is equal to 0 if quantity equal to 0 or 6. Okay, so if I set the profit becomes 0, then I'm solving this 6Q squared plus Q3 equation equal to 0. So if I take Q squared outside the bracket, inside I got 6 minus Q equal to 0. So this is going to be either Q squared equal to 0 or 6 minus Q equal to 0. And so Q squared equal to 0 means Q equal to 0, or 6 minus Q equal to 0, then Q equal to 6. Okay, so either Q equal to 0 or Q equal to 6, that is going to give the firm a 0 profit. Obtain the firm's average cost and marginal cost function. Okay, so now average cost is just going to be the total cost divided by the total quantity. So total cost is 15Q minus 6Q squared plus Q cube divided by Q. So I got 15 minus 6Q plus Q squared. And marginal cost is just the differential of the total cost function with respect to Q. So if I differentiate the total cost function, I'll get 15 minus 12Q minus 3Q squared. Okay, so that is my marginal cost. Alright, so part C asking you to confirm that marginal cost of quantity 0 is going to be equal to the average cost at a quantity equal to 0 and equal to 15. Okay, so when Q equal to 0, then average cost is, so if I substitute Q equal to 0, then average cost equal to 15, and marginal cost at quantity equal to 0 also equal to 15. Okay, and the marginal cost is minimized when quantity equal to 2, while average cost is minimized when quantity equal to 3. Okay, alright, so I got marginal cost function is 15 minus 12Q plus 3Q squared. So in order to find the minimum point, I would just have to find the first order condition, okay, where I differentiate the marginal cost function with respect to Q and make it equal to 0. So I got negative 12 plus 6Q equal to 0, and so therefore Q equal to 2. Now, to confirm that this is the minimum point, okay, where it's minimizing the marginal cost, I have to find a second order condition, which can be found by differentiating the first order condition again with respect to Q. Okay, so if I differentiate this, the first derivative again with respect to Q, I get 6, which is bigger than 0. Okay, so if the second derivative is bigger than 0, then I confirm that the value, the stationary point I found earlier, is going to be a minimum point. Okay, so therefore marginal cost is minimized at quantity equal to 2. Okay, and the value of the marginal cost at that point, which is the marginal cost at the quantity equal to 2. So if I substitute quantity equal to 2 back into my marginal cost function, I find that is equal to 15 minus 12 times 2 plus 3 times 2 squared. Okay, and that is going to be, so 15 minus 24 plus 3 times 4, which is 12. That's going to give me 3. Okay. Now I was going to find a minimum point on the average cost. So the average cost function is 15 minus 6q plus q squared. Okay, so to find the minimum point again, which is how to find the first order condition where I differentiate the average cost with respect to q and make it equal to 0. Okay, so I get negative 6 plus 2q equal to 0, and so therefore q is going to be equal to 3. Now again, I'll find the second order conditions where I differentiate the average cost, where I differentiate the first derivative again with respect to q to confirm that this is the minimum point. Okay, so if I differentiate again this expression, I get 2, and that is bigger than 0, and so therefore I confirm that q equal to 3 is the minimum point. Okay, so therefore average cost is minimized, okay, at quantity q equal to 3, and the value of the minimum average cost, which is the value of the average cost at the quantity equal to 3, is going to be equal to 15 minus 6 times 3. So if I substitute the quantity 3 into the average cost function here, then I get 15 minus 18 plus 3 squared. So that is 15 minus 18 plus 9, and that is going to be equal to 6. Okay, so part D, asking you to state the range of output Q for which the firm faces increasing total return to scale and diminishing marginal return to scale. Okay, so again, when we talk about total return to scale, we are looking at the average cost. Okay, and when we're talking about a diminishing marginal return to scale, we're talking about diminishing marginal costs. Okay, so one, increasing total return to scale, then we would like the average cost to be so we want increasing, so we want the average cost to be decreasing. Okay, in Q. Okay, so we know that average cost is minimized at a quantity equal to 0, quantity equal to 3. Okay, now so for any quantity smaller than 3, Okay, so as we found earlier in the previous part, the change in AC given the change in Q is equal to negative 6 plus 2Q. Okay, and so for any, and we want this to be we want average cost to be decreasing in Q, which basically means that we want the derivative of average cost with respect to Q to be smaller than 0. Okay, so we want the average cost to be decreasing. Means whenever quantity is higher, average cost is lower. Okay, so we want this to be smaller than 0. Then solving this inequality, I'll get negative, so I got 2Q smaller than 6, and so therefore Q smaller than 3. Okay, so for any Q smaller than 3, then average cost is going to be decreasing in quantity, and so therefore we have an increasing total return to scale. Okay, and number 2, we want diminishing marginal return to scale. Okay, now in order for us to have a diminishing marginal return to scale, we are looking at the marginal cost, and we want the marginal cost to be increasing in quantity, which basically means that the more output we produce, the higher the extra cost we will have to incur. If that's the case, then we have a diminishing marginal return to scale. Okay, so we basically want the change in marginal cost given the change in Q. We want this derivative to be, so we found earlier derivative of marginal cost is negative 12 plus 6Q. And we want this to be positive, okay, because we want the marginal cost to be increasing in Q, so we want the derivative to be positive. So therefore 6Q has to be bigger than 12, so therefore Q is going to be bigger than 2. Okay, so part E, confirm that the first order condition for profit maximization P equal to MC is satisfied if the firm chooses output Q equal to 0 or equal to 4. Okay, so the profit maximization, so we got the profit function we got found earlier, which is here. Okay, so the profit is 6Q squared minus Q 3. Okay, so the profit is going to be maximized when the differential of the profit with respect to Q equal to 0. Okay, so this is the first order condition. So then I get the differential of the profit is 12Q minus 3Q squared, and if I want to make that equal to 0, then taking 3Q outside the bracket, inside I got 4 minus Q equal to 0. So solving this equation, either Q equal to 0 or 4 minus Q equal to 0. And so therefore Q equal to 0 or Q equal to 4. Okay, now second order condition to confirm which of two of these points is going to be the point at maximizing the profit. So I just have to find a second derivative where I differentiate the first derivative again with respect to Q. So this is my first derivative. So if I differentiate this again with respect to Q, I get 12 minus 6Q. Okay, so I evaluate the second derivative at these 2 points. Okay, so at Q equal to 0, then the second derivative is 12 minus 6 times 0, which is equal to 12, and that is bigger than 0. Now if the second derivative is bigger than 0, means that Q equal to 0 is the minimum point, so it's not the maximum point. Okay, so we eliminate that because we want the point that is maximizing profit, not minimizing it. Okay, how about the second point where Q equal to 4? Then the second derivative at this point is 12 minus 6 times 4, which is equal to -12, and that is smaller than 0. Okay, so we know that q equal to 4 is a maximum point, which is what we want. Okay, so therefore we confirms that the profit is maximized at the quantity q equal to 4. Okay, so part F asking you to confirm that the profit function has a minimum at q equal to 0. Now we already found that earlier. Okay, so as shown in the previous part, okay, the profit is minimized at point q equal to 0, which is here. Okay, we already showed that. And a point of inflection at q equal to 2. Now, point of inflection is basically the point at which the second derivative is equal to 0. Okay, so if we take the second derivative and we make that equal to 0 and we solve for the value of q, that is going to be the point of inflection. Okay, so therefore our second derivative is 12 minus 6q, which is here. And if we make that equal to 0, solving this equation, we get q equal to 2. Okay, so the point of inflection is happening at quantity equal to 2. Okay, for values of output q between 0 and 6, sketch the revenue, cost and profit function. Okay. Alright, so over here I got a diagram where I want to show the total revenue, total cost and the profit. Total revenue, total cost and the profit, and I got quantity Q over here. Okay, so my total revenue function is 15Q, which is very straightforward. It's just going to be a straight line going through the origin, because when Q equal to 0, total revenue is equal to 0. Okay, and the slope is 15, so basically it's just a straight line going all the way up like this. Okay, so this is my total revenue. Now total cost is 15Q minus 6Q square plus Q3. Okay, so to draw the total cost function, so the first thing we would like to do is to find the minimum and the maximum point. Okay, so we just find the first derivative, where we differentiate the total cost function with respect to Q, and so we get 15 minus 12Q minus 2Q squared. Okay, sorry, 3Q squared. Now, so if you playing around with this a little bit, you will be able to see that it's going to, so if I take 3 outside, I get Q squared minus 4Q plus 15. Oh, outside plus, okay, just leave it like that. Okay, so here I got Q squared minus 4Q plus 4, okay, which is like plus 12, and so therefore I got plus 3 outside, so that would just become plus 15. Okay, so this would just give me, so the purpose of doing this is I just want to show you that this equal to 3 times Q minus 2 everything square. So if you expand this, you get q squared minus 4q plus 4, which is what I got over here. Okay, and plus 3. So now given that this thing is bigger or equal to 0, you plus a positive number, then this thing is always going to be positive. So showing this, I want to say that the total cost function is always going to be increasing, okay, because the first derivative is positive. So I know that the total cost is increasing all the way. So there isn't any minimum or maximum there isn't any stationary point in this case because the function is increasing all the way. Okay. Now, if we want to find a second derivative, then if I differentiate again with respect to q, then I get negative 12 minus 6q, and so as you can see, if I make this equal to 0, then q is going to be equal to 2. And this is called the inflection point, okay, just like what we did earlier. So this is the point of inflection. Okay. So now we should be able to draw roughly the diagram of the total cost function, knowing that the function is increasing and we got a point of inflection over here. Okay, so an easiest way to do is to got a little charge over here. When I got q, I got the first derivative where the change in total cost given the change in q. I got a second derivative, and I got a total cost function here. Okay, so q is going to go from 0. Now we do not care about negative quantity, so we're starting from 0. Okay, to infinity. So when q equal to 0, total cost is equal to 0. Okay, so that's the starting point. Now I got the inflection point is when quantity equal to 2. So at quantity equal to 2, this thing going to be equal to 0. Okay. Now total cost, so the first derivative, I know that is going to be positive all the way. Okay, so it's always positive. Now for the second derivative, for any quantity smaller than 2, for example quantity equal to 1, the second derivative is going to be negative. And for any quantities bigger than 2, for example quantity equal to 3, then it's going to make the second derivative positive. Okay, so what does that mean by having a positive or negative second derivative? Now the first derivative is going to tell you whether the graph is increasing or decreasing, and the second derivative is going to tell you whether it's convex or concave. Okay, so in this case, now for anything smaller than to the left of point 2, the function is increasing because the first derivative is positive. Okay, so increasing, and the second derivative is negative, mean we have a concave function. Now for anything to the right of quantity equal to 2, the first derivative is positive, again it means the function is increasing. Okay, we know that it's increasing all the way, so that makes sense. Okay, and the second derivative is positive, mean the function is convex. Okay, so therefore and at the quantity equal to 2, the total cost is going to be, so if I substitute 2 into here, I get 15 times 2 okay, minus 6 times 2 squared, which is 4, plus 2 cubed is 8, and so that is 14. Okay, so at the quantity equal to 2, total cost is equal to 14. Right, so now it should be quite straightforward to draw a diagram. So total cost is going to go through this point, the origin over here, when q equal to 0, total cost equal to 0. Now, when quantity equal to 2, which is here, I know this is the inflection point, okay? And the total cost equal to 14, so I would say somewhere around here. Okay, I'll just get a random point, it doesn't matter. Okay, I'll make it 14 healthy heat. Okay, so that is the inflection point. Alright, so now before quantity equal to 2, so any quantity smaller than 2, the function is increasing and concave. Okay, so it's going to be like this. Okay, concave, so going from 0, increasing and concave like this. Okay, and anything to the right of point 2 is going to be convex, so it's going to be like this. Okay, so as you can see, this is the point of inflection where it's changing the shape of the curve from concave to convex. Okay, and the curve is increasing all the way. So this is my total cost curve. Alright, so the profit is just going to be the difference between the total revenue and the total cost. Okay. Alright, so to draw the profit function on a diagram, I know that the profit function is, so I'm going back to my profit function where it's equal to 6q squared minus q3. Okay, and again, I already found all of the points for the profit function. So I found that the profit is going to be minimum at quantity equal to 0, maximum at quantity equal to 4, and the point of inflection is quantity equal to 2. Okay, so all of these already found in the previous part. So I just have a little chart again where I got quantity starting from 0 to 4 and going to infinity. Okay. So again, the first derivative, the second derivative, okay, and the function, the profit itself. Okay, so when quantity equal to 0, the profit is going to be equal to 0, so that's the first point. Now, when quantity equal to 4, okay, so quantity equal to 0, the first derivative equal to 0, and when quantity equal to 4, the first derivative equal to 0. Okay, we found that earlier. Okay, and quantity equal to 2, the second derivative is equal to 0. Alright, so when quantity equal to 2, the profit is going to be equal to, so did we find that? Okay, so if you substitute the quantity equal to 2 back into the profit function, you get 6 times 4 minus 8, and that is 16. Okay, and quantity equal to 4, 6 times 16 minus 4 power 3, and that is 32. Okay, so for any, so this is the maximum point. Okay, and this is the minimum point, and this is the point of inflection. Okay, now, so for any quantity from 0 to 4, then the first derivative is going to be, so if we're looking back at our first derivative over here, which is 12q minus 3q squared. Okay, so for any q smaller than 0, for any q between 0 and 4, for example q equal to 1, then the first derivative is going to be positive. Okay, so it's positive, okay. And for any q's bigger than 4, say for example q equal to 5, if you substitute that into our first derivative over here, you can see that it's going to be negative. Okay, so having this sign basically telling you that when the function is increasing or decreasing. Okay, and the second derivative for anything smaller than 2, for example equal to 1, then the second derivative, which is found over here, okay, 12 minus 6q, for example q equal to 1, is going to be positive. And for any q bigger than 2, for example q equal to 3, q equal to 4, q equal to 5, the second derivative is going to be negative. Okay, so having this, we should be able to see straight away that in this segment over here, from quantity equal to 2 to quantity equal to 0 to quantity equal to 2, the function is increasing. Okay, because the first derivative is positive, and convex because the second derivative is positive. Now for any quantity from 2 to 4, the function is increasing because the first derivative is positive. However, the second derivative is negative, meaning the function is concave. And for anything above quantity of 4, the function is decreasing because the first derivative is negative. Okay, and the function is concave because the second derivative is negative. Okay, so we know how the graph is going to look like. We know all of these important points, so we just have to plot that on a diagram. Okay, so I got q equal to 0, 2, and 4, which is here. Okay, when q equal to 2, the profit is going to be equal to 16. So that is just going to be somewhere here, I would say. Okay, and 32, we'll put it somewhere here. So when quantity equal to 4, okay, so that's the point, and quantity equal to 2, the profit equal to 16, which is here. Okay, and so I know that for anything from 0 to 2 is going to be increasing and convex. Okay, so I use, okay, so convex, which is like this, and increasing, which is like this. And for any quantity above 2 is going to be, until 4 is going to be increasing and concave. So it's going to be like this. So this is convex, okay, and this is going to be concave. Okay, I'll draw it more convex like this. Okay, so convex, and then concave and increasing. Okay, so it's keep increasing, however changing the shape. So turning from convex to concave, and for any quantity above 4 is going to be decreasing and concave. Okay, so it's going to be like this. Okay, so this is our profit function. So having this little charge over here is going to help a lot because you know what part of a diagram is going to be increasing or decreasing, and what part is convex and concave. So it's make it a lot easier when you draw a diagram. Okay, so this is our profit function, and these are all of the important points. Okay, so that's the maximum, this is the minimum, and this is the point of inflection. Alright, so the next one is just the diagram of the average marginal revenue, average marginal cost. Alright, so this one should be a lot easier. Okay, so our next diagram is here where I got average revenue, marginal revenue, average cost, marginal cost, and I have Q, okay, which is 0. Now, so we found earlier in part previously that average revenue and marginal revenue is going to be equal to the price, and that is equal to 15. Okay, so basically that is just going to be a straight line at the point 15. Okay, so this is marginal revenue equal to average revenue equal to P0. Now marginal cost we found earlier equal to 15 minus 12Q minus 3Q squared. Okay, so that's what we found earlier, which is here. Okay, and we also found that at a quantity equal to 0, marginal cost is equal to 15, okay, which is here. So that's the first point. And we also found that the marginal cost is going to be minimized at a quantity equal to 2. Okay, so therefore we know that it's going, so at the quantity equal to 0, so we found earlier that at quantity equal to 0, marginal cost equal to 15. Okay, so that is going to be the point over here. Okay, so this point is on the marginal cost, and at the quantity equal to 2, then marginal cost is minimized. Okay, and the value of the marginal cost at that point we found earlier is, which is here, yep, which is equal to 3. So we just have to do that. So at the quantity equal to 2, I'll put it here. Okay, so I'll say 3 over here. So this is the minimum point on the marginal cost. Okay, so I should be able to draw, so looking at the marginal cost function, I know that it's a quadratic function, and I know that it's going through these 2 points, so it should be straightforward to just draw marginal cost like this. Okay, so very similar to draw an average cost. Now, so my average cost is 15 minus 6Q plus Q squared. Okay, and again we found earlier when Q equal to 0, average cost is equal to 15, so that it's just going to be the same point over here. Alright, and we also found that when Q equal to 3, average cost is minimum. And the value of the average cost at that point is equal to, so by going back, I found earlier over here, equal to 6. Okay, so plotting that on a diagram with Q equal to 3, I would say somewhere here, equal to 6. So okay, I'll say it like this. Okay, so that's the minimum point. And how do I know it's on the marginal cost curve? If you substitute the point 3 into the marginal cost function, you will find that marginal cost is going to be equal to 6. Okay, so it is going to be on the marginal cost curve as well. And this is the minimum point of the average cost. So when you draw the diagram, it's going through this point over here and minimize at this point. Okay, so this is my average cost. Alright. And so the last part is asking you, suppose that the market price falls to P1. How should the firm react if P1 is bigger than 6 and if P1 is smaller than 6? Okay, so if the market price is now P1 and if P1 is bigger than 6, what would happen? So as you can see over here on the diagram, at the value of 6, that is the minimum point on the average cost. Okay, now so if the price is above 6, so I would say the price is somewhere, I use the different color, say the price is somewhere, so it's not 15 anymore, okay, but it's now equal to 6. So it's now, so if the price is now bigger than 6, but not equal to 15. Okay, so say somewhere here, so this is P1. Okay, so it's above 6, however smaller than 15. So if that is the case, then how should the firm react? So the firm is going to be producing at a point where marginal revenue equal to marginal cost in order to maximize the profit. Okay, so we already know that. So the point of production is where so this is the new marginal revenue equal to average revenue equal to P1. Okay, so marginal cost is here, marginal revenue is here, so this is the point of production. Okay, now at this production quantity, so I would say this is Q star, which is maximizing the firm's profit. As you can see, at this quantity, this is the price P1 and this is the quantity, sorry, this is the average cost corresponding to Q star. So the price is higher than the average cost, so the firm is making profit. Okay, so therefore the firm is going to continue to produce because the firm is making profit, and so therefore more firm is going to enter the market because they can see the profit inside the market. Okay, so I would say when P is bigger than P1 is bigger than 6, firm will produce at the point where marginal revenue equal to marginal cost, okay, to maximize the profit. Okay, and so that is the quantity Q star. So as you can see at Q star, P1 is bigger than the average cost at Q star. Okay, so the firm is making profit. Positive profit. Okay, so therefore, if the firm from the outside the market see that the firm inside the market is making positive profit, then more firm is going to enter the market. Okay, now the second case is where P1 is smaller than 6. So I would say I would draw a line where P1 is smaller than 6. I would draw it somewhere over here, for example. Okay, so this is now P1. And this is marginal revenue equal to average revenue equal to P1. Again, the firm produces at a point where marginal cost equal to marginal revenue to maximize profit, which is this point over here. Okay, so outside this is Q double star. So as you can see at Q double star, this is the price P1, and corresponding to Q double star going up all the way to the red curve, this is going to be the average cost. And as you can see, the cost is higher, so this point is higher than this point, so the cost is higher than the price. Okay, so firm produce maximum profit at Q double star. Okay, and at Q double star, then P1 is smaller than the average cost at Q double star. Okay, so therefore the firm is making loss or negative profit. Now if that's the case, then they will exit the market. Okay, now I wouldn't want to stay in the market if I'm making a loss, so the firm will exit the market.